Well, integration using trigonometric substitution. And this one, we're having algebraic integration, and we're going to convert it to trigonometric substitution to make it easier. But for this one, there are three forms that we can substitute or convert to trig functions. So the first form is a square root of a squared minus x squared, which is related to sine. The second form is a squared plus x squared. And the third one is x squared minus a squared. Okay, and here we're gonna have a sine form, which is gonna be x being equal to a sine theta. And now we're going to substitute in the equation that we're having. There's a squared minus a squared sine squared theta. So this one is going to equal a squared 1 minus sine squared theta and we're going to get a squared cosine squared theta. So this one is just going to be a, where a is a positive number. A is a positive number. And then cosine squared theta under the square root is absolute value of cosine theta. But for example, if we have this angle from minus pi over 2 to pi over 2, then it is going to be cosine is going to be positive, and we can pull it out of the absolute value. Therefore, we're going to have a cosine theta, and makes the life a whole lot easier. The second one is tangent. X with plus sign, it is going to be tangent. X is a tangent theta. And now we're going to substitute in the equation that we're having. It's going to be a squared plus a squared tangent squared theta. So we're going to have a squared 1 plus tan squared theta. And 1 plus tan squared theta is secant squared theta under the square root is just going to be a secant theta. And now the third one is x squared minus a squared under the square root, and this one, in this case, we're gonna have x being equal to secant theta. Which is gonna be secant theta, I'm sorry, it's gonna be a secant theta. It's gonna be a secant theta. And now we're gonna substitute this in this equation. We're gonna get a squared secant squared theta minus a squared, and this one is gonna equal a square root of a squared secant squared theta minus 1 in parentheses. And here a squared becomes a, secant squared minus 1 is tan squared, and comes out of the square root becomes tan theta. And now let's solve some problems related to these functions or related to this topic. This is problem number 1. I equals 4 minus x squared under the square root divided by x squared dx. So in here we're gonna have integral of, but before writing the integral of, let's do the substitution. X equals 2 sine theta. Therefore, dx is going to be 2 cosine theta d theta, and then, of course, sine theta is going to be x divided by 2. We're going to be using this one later, not now. And now we're going to substitute the value of x, which is 4 minus 4 sine squared theta under the square root, divided by x squared is just going to be 4 sine squared theta. And dx is 2 cosine theta d theta. All right. So we're gonna have integral of, this is 4, common factor 1 minus sine squared theta under the square root divided by 4 sine squared theta, and here we're having 2 cosine theta d theta. Okay, 1 minus sine squared theta is going to be cosine theta. Cosine squared theta under the square root, we just say it is cosine theta, and there is no need to mention the absolute value in this case. And we're going to have 4 under the square root. When we take it out, when we pull it out, it's going to be 2 cosine theta, which is 4 sine squared theta times 2 cosine theta d theta. So we're going to have or we're going to reduce this 2 times 2 is 4 with this one. We're going to cancel these. And we're going to get cosine theta times cosine theta, which is cosine squared theta d theta. This is problem number 2. We can solve it later. Okay. And this one is cotangent squared theta d theta. We know that cotangent squared doesn't have a closed form solution. The integral of cotangent squared doesn't have a closed form solution. Therefore, we're going to convert this to cosecant squared theta minus 1 d theta. And we know that the derivative of cotangent is cosecant squared. Therefore, the integral of cosecant squared, of course, cotangent, the derivative of cotangent is minus cosecant squared. Therefore, the integral of cosecant squared is just going to be minus cotangent theta and minus theta is here. Of course, this is the end of the integral, but the original variable was x, whereas here we're having theta. We have to take it back to the original variable, which is x, and we had sine theta being x over 2. Therefore, we're going to plot a right angle triangle with this angle being theta. This is the 90 degrees. So x is going to be opposite, because in sine we have x being opposite, and the denominator is the hypotenuse, which is 2. Therefore, 2 squared minus x squared is the adjacent side. Of course, it should be under the square root, like this. And now cotangent, this is minus sign. Cotangent is adjacent divided by opposite. Therefore, we're going to have adjacent, which is 4 minus x squared divided by x, minus, if sine theta is x over 2, therefore theta is just going to be sine inverse of x over 2 plus c, and here is also plus c. And this is our integral. So we're done with this problem.